Meet Maya. She just finished her first science experiment, measuring the boiling point of water. Her teacher says the real answer is 100 degrees Celsius, but Maya got 97. She stares at her paper wondering, is that good? Is that terrible? How do scientists even measure how wrong they are? That's exactly what percent error is for, and by the end of this video, Maya and you will know exactly how to figure it out. So, what exactly is percent error? It's a way to measure how far off your answer is from the correct answer, expressed as a percentage. Scientists, engineers, and mathematicians use it all the time. Think about it. If you're baking and you need exactly 1 cup of sugar, but you add a tiny bit more, is that a big deal? Percent error helps us answer questions like that. It tells us not just that we were wrong, but how wrong in a way everyone can understand. Here's the formula that makes it all work. Percent error equals the absolute value of your measured value minus the actual value divided by the actual value times 100%. Let's break that down. The absolute value means we always make it positive because we only care about how wrong we were, not whether we went high or low. Then we divide by the actual value to make it a fair comparison, and multiplying by 100 turns it into a percentage. Simple, right? Let's see it in action. Let's make sure we understand every piece. Your measured value is what you got, your experiment result, your estimate, your calculation. The actual value, also called the accepted value or true value, is the correct real answer. The difference between them is your error. By dividing by the actual value, we scale that error fairly. A difference of 5 degrees matters a lot if the actual value is 10, but barely at all if the actual value is 10,000. That's the beauty of percent error. It gives us context. Now here's a great question. What counts as a good percent error? In general, a percent error under 5% is considered pretty good for most school experiments. Under 1% is excellent. That's what professional scientists aim for. Over 10% usually means something went wrong, but it really depends on the situation. Measuring the length of a football field, 2% error is fine. Measuring medicine for a patient, even 1% could matter. Maya got about 3% error in her experiment, which is actually pretty solid work. Let's verify that together. Let's solve Maya's problem. She measured 97 degrees Celsius, but the actual boiling point is 100 degrees Celsius. Step 1. Find the absolute difference. 97 minus 100 equals -3, but the absolute value makes that +3. Step 2. Divide by the actual value. 3 divided by 100 equals 0.03. Step 3. Multiply by 100%. 0.03 times 100 equals 3. So Maya's percent error is 3%. That's well under 5%. Great job, Maya. She measured the boiling point with impressive accuracy for a classroom experiment. Quick pause. Let's talk about those absolute value signs. Why do we use them? Imagine you measured 103 degrees instead of 97. You'd get 103 minus 100 equals +3. But with 97, you'd get 97 minus 100 equals -3. In both cases, you are off by 3 degrees. The error is the same. Absolute value removes the negative sign, so we're comparing size of error, not direction. It doesn't matter if you measured too high or too low. What matters is how far off you were. That's a key insight. Here's a fun one. Jordan estimates there are 520 people at a school basketball game. The actual attendance was 500. Let's find the percent error. Step 1. Absolute difference. 520 minus 500 equals 20. Absolute value of 20 is just 20. Step 2. Divide by the actual value. 20 divided by 500 equals 0.04. Step 3. Multiply by 100%. 0.04 times 100 equals 4. Jordan's percent error is 4%. Pretty close estimate for a crowded gym. Jordan's counting skills are solid. This is under 5%, so we'd call that a great estimate. Priya is making decorations and cuts a ribbon she thinks is 45 centimeters long. She measures it afterward, and it's actually 50 centimeters. Oops. Let's find the percent error. Step 1. Absolute difference. 45 minus 50 equals -5. Absolute value is 5. Step 2. Divide by the actual value. 5 divided by 50 equals 0.1. Step 3. Multiply by 100%. 0.1 times 100 equals 10. Priya's percent error is 10%. That's right at the edge. She was off by a full 10%. She might want to measure more carefully next time. Last example. Ethan uses a scale in science class and measures a rock at 392 grams. The actual mass is 400 grams. Let's calculate the percent error. Step 1. Absolute difference. 392 minus 400 equals -8. Absolute value is 8. Step 2. Divide by the actual value. 8 divided by 400 equals 0.02. Step 3. Multiply by 100%. 0.02 times 100 equals 2. Ethan's percent error is 2%. Excellent, that's well under 5%. The school scale is working great, and Ethan measured carefully. Science class is going well for him. Before we wrap up, let's talk about the mistakes students most often make with percent error. Mistake number 1, dividing by the measured value instead of the actual value. Always divide by the actual. Mistake number 2, forgetting the absolute value and getting a negative percent error. Percent error is always positive. Mistake number 3, forgetting to multiply by 100 and leaving your answer as a decimal, like 0.03, instead of 3%. And mistake number 4, using the wrong value as actual. The actual value is always the accepted, correct answer, not your measurement. Here's the really cool part. Percent error shows up everywhere in the real world. Weather forecasters use it to check how accurate their temperature predictions were. Engineers use it to make sure bridges and buildings are built to exact specifications. Pharmacists use it to verify medicine doses are correct. Even NASA uses percent error to check spacecraft measurements. And you've been using it today, just like a scientist. Maya started this video confused about whether her 97-degree measurement was good, and now she knows. 3% error is excellent science work. You both should be proud. Look how far you've come. Remember when Maya was staring at her worksheet wondering if 97 degrees was close enough? Now she and you can calculate percent error in 3 easy steps. 1. Find the absolute difference between measured and actual. 2. Divide by the actual value. 3. Multiply by 100%. Keep your percent error under 5% and you're doing great science. Under 1%, you're basically a professional. From confused to confident.